So, dear students, today we start first chapter of 12th standard physics, and name of the chapter is Rotational Dynamics. We study this chapter, Rotational Dynamics, and in the first topic we study is a circular motion. Circular motion. Now, what is the meaning of the circular motion? Motion of the particle along the circumference of the circle is called the circular motion. We have studied in 11th standard this definition of the circular motion. Motion of the particle along the circumference of the circle, that is called the circular motion. There are two characteristics of the circular motion, and first characteristic is it is accelerated motion. Circular motion is a accelerated motion. Means why it is called accelerated motion? Because the motion of the particle, or in this circular motion, the velocity of the particle is continuously changing. Direction of the velocity of the particle is continuously changing, and therefore it is called accelerated motion. Means if you draw a figure in which there is a particle, this is a particle, and it is moving along the circumference. This is a circular motion. This is center, this is radius vector r, and this is the linear velocity of the particle, and it is tangent to the circle at point P. And suppose this particle is at point Q. At this point, velocity will be vector v. It is tangent to the circle. Means direction of the velocity is continuously changing, therefore it is accelerated motion. Then second characteristic of the circular motion is it is a periodic motion. It is periodic motion because this motion is repeated again and again in the equal interval of time, and so it is a periodic motion. म्हणजे हा पार्टिकल इथे सर्कल मध्ये फिरतोय, सर्क्युलर मोशन असताना सर्कल मध्ये फिरतोय, आणि पुन्हा पुन्हा हा पार्टिकल एका विशिष्ट टाइम इंटरवल मध्ये पुन्हा एकाच त्याच पॉइंटला येतो, आणि ही घटना पुन्हा पुन्हा रिपीट होते. मीन्स द मोशन इज रिपीटेड अगेन एंड अगेन in equal interval of time, and so it is a periodic motion. Then we see what is the kinematics of the circular motion. Now kinematics is the branch of the physics in which the motion of the particle is studied or is then discussed without its cause. म्हणजे त्याच्या कारणचा अभ्यास न करता त्या पार्टिकलच्या मोशनचा अभ्यास केला जातो, आणि ती ब्रँच आहे ती म्हणजे कायनेमॅटिक्स असते. मग कायनेमॅटिक्स मध्ये अभ्यास करताना मग कोणत्या फिजिकल क्वांटिटीजचा तिथे अभ्यास होतो की ज्यांच्या कॉजची काही गरज नसते, त्याच्यामध्ये ते कारणांचं काही डिस्कशन नाही केलं तरी चालतं. तर अशा ज्या फिजिकल क्वांटिटीज आहेत त्या म्हणजे डिस्प्लेसमेंट आहे, डिस्प्लेसमेंट, नंतर डिस्प्लेसमेंट एस, नंतर आहे वेलोसिटी वेक्टर v, नंतर आहे ऍक्सेलरेशन, ऍक्सेलरेशन असतं वेक्टर k. या तिघे फिजिकल क्वांटिटीजचा अभ्यास करताना कॉजेसची गरज नसते. मग इथे हे कायनेमॅटिक्स मध्ये येतात. आणि all these three physical quantities are in the translational motion, or they are in the linear motion, they are straight line motion. And actually in this chapter we are studying circular motion. म्हणजे आपल्याला इथे सर्क्युलर मोशनचा अभ्यास करायचा आहे, म्हणून आपल्याला इथे त्याचे ॲनालॉगस ज्या फिजिकल क्वांटिटीज आहेत त्याचा अभ्यास करावा लागेल. सो ॲनालॉगस फिजिकल क्वांटिटीज आर अँग्युलर डिस्प्लेसमेंट, इट इज थीटा. देन angular velocity, it is omega. Then angular acceleration, it is alpha. So these three quantities are analogous quantities. त्याच्यासारख्याच त्या quantities आहेत, and these three quantities are in the circular motion, they are in the angular motion, they are in the rotational motion. These three quantities are used in the rotational or circular or angular motion. Then the tangential velocity vector v, it is also called the linear velocity of the particle in circular motion, and this tangential velocity is given by vector v equal to omega cross r. हे इक्वेशन आपण 11वी मध्ये फाइंड केलं. We have discussed this equation in 11th standard, and magnitude is v is equal to r into omega, where omega is the angular velocity. Now here, if you look at this figure, or if you draw another figure, suppose this is the particle revolving along the circumference of the circle. Then this is center, this is point P, then this is radius vector r. This is radius vector r. Then this is direction of the linear velocity vector v. It is perpendicular to the radius vector. Then the direction of the angular velocity is shown by this arrow. This is the direction of angular velocity, and the direction of the angular velocity is given by using right hand thumb rule. Now according to right hand thumb rule, if you imagine your right hand such that the four fingers are curved around the axis of rotation and the thumb is stretched in upward direction. If you imagine like this, and if the motion, the curved finger shows the motion, circular motion, then the thumb shows the direction of the angular velocity. So this is called the right hand thumb rule. This right hand thumb rule gives the direction of the angular velocity omega, and it is shown in this diagram. In this diagram, vector r, vector v are perpendicular, and this omega vector is perpendicular to vector r. So this is the vector diagram to show the direction of the angular velocity omega. Then we see what is the relation between period and omega. Omega is equal to 2 pi upon t. This is the formula of the omega. We say omega means angular velocity, and angular velocity equal to 2 pi divided by t. This is the formula of angular velocity. Then it is also equal to 2 pi n, where n is the frequency. Then we say what is meaning of the UCM? UCM means uniform circular motion. When in circular motion, if the speed of the particle is constant, that motion is called uniform circular motion. If you make the ceiling fan on, and after some time the ceiling fan revolves with constant speed, and that is called the uniform circular motion. That is the example of the uniform circular motion. When particle performs uniform circular motion, the tangential velocity of the particle is tangent to the circle, or therefore it is called a tangential velocity, and the acceleration which is responsible for this circular motion is called centripetal acceleration. And this acceleration which is responsible for this circular motion, which is responsible to change the direction of the velocity of the particle, that acceleration is centripetal acceleration. Why it is centripetal? Because it is directed toward the center. This acceleration is directed toward the center, and therefore it is called a centripetal acceleration. It is also called the radial acceleration because it is along the radius, therefore it is called the radial acceleration. So it is called the radial acceleration. It is given by vector AR is equal to minus omega square vector R. This is formula. Then its magnitude is omega square R, AR equal to, and it is equal to B omega, and it is same as B square upon R. This is the magnitude of the centripetal acceleration. This is magnitude of the radial acceleration. So radial or centripetal acceleration is the acceleration which is directed along the radius and toward the center, which is responsible for the circular motion, and it changes the direction of the velocity of the particle, that is the centripetal or radial acceleration. So this is about the uniform circular motion. Then non-uniform circular motion. When the particle is in circular motion and if the speed of the particle is not constant, that motion is called a non-uniform circular motion. For example, if you switch on the fan, initially it is raised. After some time, the speed will go on increasing. The speed is not constant, and therefore this motion is called the non-uniform circular motion. This is the example of the non-uniform circular motion. In non-uniform circular motion, there is a centripetal acceleration or radial acceleration acting on the particle. Radial acceleration or centripetal acceleration is there on the particle. It is directed toward the center. It is along the radius. But there is additional acceleration acting on the particle when the particle is in the non-uniform circular motion. That is tangential acceleration, and this tangential acceleration causes the change in the speed of the particle. The speed of the particle is changed by the tangential acceleration, and that tangential acceleration is the acceleration which is acting in the direction of the tangential velocity or opposite to the direction of the tangential velocity, which is responsible to change the speed of the particle, and that acceleration is called the tangential acceleration. So this is uniform circular motion. In uniform circular motion, there is tangential acceleration as well as there is a centripetal acceleration. Now when the particle is moving with the constant speed, means when there is when particle is in uniform circular motion, at that time the direction of theta vector, direction of omega vector, and direction of alpha vector they are in the same direction, and that direction is given by using right hand rule. It is given by using right hand thumb rule. So direction of theta, omega and alpha is given by right hand thumb rule. And this is all about today's lecture. We have covered 4 topics in this lecture. We see next part in the next lecture. Thank you very much.